Hello, everyone, and welcome to Physics 205, Physics for Movement Science. My name is Jeff Gagnon, and I will be your instructor for this course. So basically, this is a one-semester introductory physics class that you can think of it as a survey physics class, but in particular, it's designed to prepare you for the Applied Exercise Science 319 course, which is kinesiology and biomechanics. So this class will provide you with the basic physics skills and math skills needed to start understanding human movement. So on the bottom here, I have a couple of examples of human movement in biomechanics. So the one on the left here, this is someone performing a standing vertical jump. So you could model that by having a trunk segment, a leg segment, or a thigh segment, a leg segment, and a foot segment. And then you could calculate a bunch of information about the jumps. You could calculate torques about the hip joint, the knee joint, the ankle joint, that sort of thing. So modeling is a big important factor in biomechanics. The picture on the right is someone performing just a walk, so natural gait. But in this case, they have all these markers attached to their body. And she would be surrounded by several cameras, maybe 7 to 10 cameras. And using all the information from the cameras, they will give you the position of the markers. And then once you know the position of the markers, you can figure out all sorts of things like the angle of the limbs, the relative angles between limbs. You could figure out the angular velocity of the limbs. You could even figure out joint torques and things like that, especially if you have a force platform that records the external forces that are applied when she contacts the ground, okay? These are just examples of some things that you would actually do in biomechanics or movement science. Now, unfortunately, this class will not go this far. I mean, to get to this point, you really need to take several classes in biomechanics. Okay, so what is physics in general? So physics is a study of the basic nature of matter and the interactions that govern its behavior. It's really the most fundamental of sciences, although some people will argue mathematics is, but in terms of science in general, physics is considered to be the most fundamental. For example, when you study biology, it depends a lot on chemistry, right? You need to know chemistry to do biology. Well, in turn, chemistry depends on physics. So ultimately, like physics is sort of the ground. It's the fundamental science on which everything else depends on. Now, biomechanics, or human movement science in particular, draws on techniques particularly from mechanical engineering, but mechanical engineering ultimately relies on physics. In particular, it relies on the topic of mechanics. Okay, so that's why we need to study at least the basics of physics so you can start understanding human movement. Okay, what are some main subfields of physics? So physics is a broad area. There's several topics that are covered in physics. One of them is mechanics, electricity and magnetism, thermodynamics, optics. You may have heard of quantum mechanics, or Einstein's general relativity, special relativity, right? These are all areas of physics that can be studied, and people spend, their entire lives on one small subset of one particular area. This class is going to focus just on mechanics, so I have it highlighted here. And mechanics is really the study of forces and motion, right? So we need to do that to understand human motion. Now, again, mechanics is a huge topic. It's a huge subject. To really understand it fully would require, maybe 4 or 5 classes and probably graduate work as well. So we're just going to touch upon the basics in this particular course. So to give you an idea of the things that we're going to be covering in this course, go to the next page. So we'll talk about physical quantities and units, and then how to convert between different units. We'll talk a little bit about significant figures and how to represent your answers. We'll spend a lot of time talking about the addition and subtraction of vectors and finding components of vectors. And we'll do this both graphically, so how to add and subtract vectors graphically in other words, using a protractor and ruler, and also how to add and subtract vectors analytically. So using basically mathematics, using trig functions, sines and cosines. We'll get into one-dimensional kinematics. So kinematics is basically the study of motion without regard to the forces. So things like displacement, velocity, acceleration, those are all topics that we'll study in kinematics. We will look at graphical interpretations of 1D, one-dimensional motion. So given position versus time graphs, velocity versus time graphs, and acceleration versus time graphs, we'll look at how to interpret those graphs. And then we'll spend a little bit of time looking at some applications, so solving some application type problems that involve constant accelerated motion. Then we'll turn to, well, free rise, free fall motion really is constant acceleration motion as well, where the constant acceleration is the acceleration due to gravity. So that's like vertical motion that we'll study. Then we'll get into two-dimensional motion. We'll talk about projectile motion, which in that case, the motion occurs in both the vertical and the horizontal directions. Then we'll transition into dynamics, which is the study now of the forces and or the forces that cause the motion. So now we're going to look at the actual cause of the motion. So we'll look at Newton's 3 laws of motion, which is really important. We'll spend, again, a lot of time solving problems, looking at applications of Newton's laws. Then we'll get into circular motion. In particular, we'll look at something called centripetal acceleration and centripetal force, which again also involves Newton's laws. We'll spend quite a bit of time looking at translational and rotational equilibrium. So this is when objects are either at rest, they're static, or they're moving with constant velocity, either translating or rotating. Then we'll talk a little bit about the rotation motion of a rigid body. So looking at torques, moment of inertia. Finally, we'll talk a little bit about the work energy theorem. So we'll define work, define kinetic energy. We'll see how they're related. And in particular, we'll focus on conservation of mechanical energy, and we'll use it to solve some problems, okay? So that sort of gives you a brief idea of the type of topics that we'll cover in this course. And in here, I gave you another example from biomechanics. Here's sort of a gait cycle. So 0% is heel contact. And then there's toe off right here, about 60% of the way in. And then 100% is that heel contact with the right foot again. And what you're shown on the graph here, this is the vertical force that's being applied to the body. So if you had like a ground reaction force, if you had a force plate, you could record this ground reaction force. This would be like the force in the vertical direction that's applied to the foot or to the body as you're performing that walk. And then this is going to be the horizontal force, or this is sort of like the anterior posterior force. At first it's negative because it's like resisting your motion, right? You're slowing down. And then at this point, you're pushing off and you're speeding up so that you have a positive force in the anterior direction. Well, if you combine these vertical and horizontal forces, you can represent them as vectors. So again, when we talk about vectors, here's one example. So a vector has both magnitude and direction. And again, you can split it up into a vertical component and a horizontal component. So this is the same information that's given here, but it's given in vector form. So that's one instance of why vectors are important, okay? And then the last slide here, I just want to give credit to those images that I used. They come from this book. It's an excellent textbook. It's really a graduate level textbook though, called Biomechanics of Movement, the Science of Sports, Robotics, and Rehabilitation by Uchida and Delp. Okay, great. So I hope you enjoyed this class, and I'm excited to be teaching it this semester. Thank you.